Hello, hello. Are we live? Cool. Welcome back to the Advent of Sintran. This is 2024, day 13. So, let me download my input. Okay, we've got buttons and prizes. A, B, X, Y coordinates. Buttons. 1,300 lines of input, nearly. All right. Here's my template. And then let's read the puzzle. I usually like to get the test input first before I actually read anything. I guess I'm worried I might forget if I don't do it almost immediately. Okay, now I think I've got a couple extra new lines here because I have some sort of copy-paste bug. So 4 groups of 3 lines with spaces in between. Yeah, that's what that should look like. Okay. We have an arcade, claw machines, joystick, but just no joystick, just A and B buttons. 3 tokens for A and 1 token for B. So I hope we never have negative numbers. Okay, we never have negative numbers. Everything is positive X and positive Y. That means we can just kind of search, and if we ever overshoot, we can abort the search. If there were negative numbers, it would be more complicated than that. You would just be searching indefinitely. Just the first claw machine. Okay. So it's kind of going to be another search problem. Depth first or breadth first. Not all of these have a solution. Okay, and then we just sum the optimal number of tokens. And that's the answer. Oh. No more than 100. Well, you can kind of deduce that by the fact that there are no negatives. If you ever overshoot, you can stop. So this is like a redundant rule. I don't know why they add it. Okay. That doesn't seem too bad. So we're searching in a space of button presses. You can either press A or B, and it's kind of like a binary tree. We're gonna, one leg of the binary tree is press A, and the other leg of the tree is press B. And then every time you make that choice, you have another node below where you have the same choice again, A or B. So you're searching through a binary tree to try to get to a certain position by pressing buttons A and B in some combination. Is it even that complicated? Is this not just like a simple algebra problem? You have to get like the exact coordinates. Let's think about this for a second. So you have AX, AY, BX, and BY, and then you have prize X and prize Y. That's essentially the input. 6 numbers for one claw machine. Each one of these groups of 3 lines is 1 claw machine. So this is 1 claw machine. It's 6 numbers. And now we kind of have an equation to solve and an optimization problem. So you have NA times... let's factor each dimension individually. And then NB times BX. This is the X equation. That's going to be PX. And then this again, but Y. So whenever I have X, replace that with Y. Okay, this is the set of equations that we have, but we have 2 equations and we have 4 unknowns. Is this a classic optimization problem? Constrained optimization? And then we want to minimize, what does it cost? I think the costs are like constant. 1 token, 3 tokens for A and 1 token for B. And then minimize 3 for A plus that. So let me write the first part as a matrix because that's the way these are typically written for optimization problems. So NA and NB are like the unknowns, and then AX, BX, AY, BY is the matrix, and then PX, PY is the right-hand side. So the matrix A, AX, BX times, hold on. So this is a matrix equation, so it's not really done until I write the second line. Replace that with Y, and then this is NB. So this 4x4 thing is a matrix. Whoa. And then this is a vector, and then this is another vector. And if you expand this matrix vector product, you just get these 2 equations. If you prefer to think of it as a system of 2 equations. So, and then you still want to minimize. There's is this linear programming? I think there's no, or there is a constraint. Yeah, we have to have a positive number of button presses. Can I solve this? Is it easier to implement the linear programming solution than it is to just wing it, because I was thinking of winging it until I recognized that this is an optimization problem. Okay, how do you solve it? What's the algorithm? Variations, algorithms, simplex. Sounds complicated. I've done simplex algorithms. Nelder-Mead simplex. Okay, fuck this. I think we're just gonna wing it. It's not really less than or equal. We want equal. So is this even an optimization problem? Yeah, we have a matrix vector equation that's equal. So it's actually not this. It's similar to this. There's probably some name for this problem. But I think the simplest thing is to search the binary tree. That was my first idea anyway. So I think I'm going to do it that way. Okay, I should be able to echo the input. And there's the input. We're going to iterate through this one claw machine at a time. So we're not going to load the whole thing. We're going to read 4 lines and just work with that. So we have a bit of a parsing problem here. It's always button A and then button B. They never do anything weird like give it to you out of order. Okay, so I think I want to yank that so I can look at it. Okay. Yeah, we want to do while not EOF, and then I think I actually want to get 3 lines at a time here. So I just want to parse 2 numbers out of this line and ignore anything that's non-numeric. And I already know that there are never any negative signs. So you don't have to do anything special for that. And I think I have a function for that in my utils. I can't remember which one it is. So is it read or is it parse? Read I32. Read I32s. Okay. This parses a vector of integers from a string, and any non-int characters are treated as delimiters. So that's what I want. Read I32s. Do I have a 64-bit version? I don't. I probably won't need it. Yeah. I think. So from the string, and I think that only takes 1 argument. Yeah, it only takes a string, and then it returns a vector. I hope that works. So we do that. Then we read another line. I have this one here. So then we're going to get the B's, and then we're going to get the prizes. Okay. So, and then we read 1 more line. Then we want to skip the blank line. And then you start the loop over again, so that's why there's 1 more at the bottom. So let me just verify that I read that correctly. I'm going to just print that one for now. I probably want to print all 3 though. So we have that. Let me just open this. 9434, 2666. Oh, yeah, I want to look at these. 1786 and 6923. Okay, let's print the other two just to make sure. B, P. Okay, 2267, 6721, 8400, 5400. That number, that number. Okay, these all seem to be correct. And we get the last one too. We don't have any off by one end of file issues. Okay. Now, how do I solve this? Yeah, I guess we're going to search the binary tree. Maybe I want to unpack these vectors into a bunch of scalars. Or leave them as vectors, but then I'm going to have to type a bunch of brackets. It doesn't matter. And then you don't even need to search a tree. You can just add them up. Yeah, so I feel like we can probably brute force part one. Yeah, you don't need to think about it as a tree, really. Maybe you can if it helps, but you don't have to have like a queue. I was thinking I would have to write a queue here to like do a depth first search on a tree, but that's way overcomplicated, at least for part one. How big are these numbers? This is, what the hell is that? Like up to 20,000 maybe? Yeah, why not just brute force this? That's what the tree search would do anyway. It's equivalent to brute forcing with 2 for loops. So we're going to have zero through n max. N max is 100 because they tell us we're limited to 100 button presses. Where does it say that? It says 100. There we go. No more than 100 times. No more than. So you can do 100. You can do 99. You can do 100. You cannot do 101. So I actually want to loop. It's exclusive of the upper bound, so I want to make it inclusive of n max. So I have to add 1. And then similar for B. And then we're going to check if the coordinates match, and then we're going to compute the cost. And if the cost is the best cost we've seen so far, then we're going to save that as our optimal answer. So so we also have fixed costs for A and B. I think it's 3 and 1. I want to make sure I don't get these mixed up. I think A is 3. 3 tokens for A and 1 for B. 3 for A. Okay, I got those right. So let's just like, we have to initialize this to some big number that's bigger than any cost we'll actually calculate. So let's do cost A times nmax plus cost B. I don't know, plus 100. Why not? Just to be safe. Yeah. I think you could add 1. You could add 0, but then you're actually going to run into that initialized number inside the loop. And that's just too close to being ill-defined for me to like not add some number there. Or like multiply by a safety factor. That would be fine. Okay, now the actual cost. No, we don't have to compute the cost yet. First, we want to see if this even gets us to our position. So NA times VA plus NB times VB. Right? I think that's it. And then if all V equals the prize position, you could do whole vector equations like this in Syndrin. I don't think I had this feature last year. So this is a vector and this is another vector, and you can multiply them by scalars and then add vectors together and you get another vector. And then you can compare whole vectors and use the all function to check if both the x coordinate and the y coordinates match. Yeah, so that's what this compact code means. This is the same way you could write things in Fortran or MATLAB, or probably Julia. I've barely used Julia, but I assume it's on par with Fortran and MATLAB for most things. Okay, so if this gets us to the correct location, then we can compute the cost. That's going to be NA times cost A plus NB times cost B. And this is just a scalar equation. It looks a hell of a lot like this equation, but everything in this one is scalars, not vectors like we have there. And then if the cost is better than any optimal cost that we've seen so far, I don't think it matters whether you do less than or equals. Yeah, it actually doesn't matter. Actually, do we need to save? I don't think we need to save these things. We just have to know what the cost is. So we don't even need a if statement. We can just do cost opt equals min cost opt cost. And there's a chance that this will never get initialized. So you could like compare it to this initialized value, but I think I want a Boolean because that feels cleaner. And then if found sum plus equals cost opt. Pretty sure that's going to be part 1. Let's see if I get the test input correct. 480. I remember that was correct, so nice round number. It was 200 plus 280, so this is not bad. It's flying through the input. I'm worried about part 1 because I'm worried about part 2 because part 1 is too easy here. Okay, yeah. Now you can't brute force this. What even is this number? Is that a trillion? I'm going to have to use 64-bit integers to begin with. I think unless A and B are collinear, think of these as vectors. Unless A and B are collinear and they're both collinear with the prize, then you're never going to have multiple solutions. You're only going to have one solution. And if A and B are collinear and they're not collinear with the prize, then you're not going to have any solution. So you don't need to iterate. You can just like divide. but it is a vector equation. And we're dealing with integers, so that makes it weird. Usually with matrix problems, I'm dealing with floats, so you can divide, but this is kind of weird. Okay, so what's this number? Let's make this more readable. I'm allowed to do this in Syntran now. 10 trillion? Thousands, millions, 10 trillion. Okay. That's a big number. And that has to be... It's going to be automatically inferred as I-64, but why not explicitly say it? Okay. So first of all, let's just repeat part 1 and make everything 64-bit and make sure that I can still do that without type checker. Excuse me. Any type checker problems? So I'm not even going to do anything with this yet. It's a constant. So this is part 2. Okay. And then at the end, let's get rid of some of this dead code. That is not needed. That is not needed. Don't need to echo everything. Let's go back to the test input. Okay. I didn't even change my types yet. This should just run part 1 twice, 480, 480 for the test input. Okay. Let me change my types. So basically everything is going to have to be 64-bit. You are allowed to like mix and match things. So when I multiply a cost by some number, you can have an I-32 multiplied by an I-64, and then the result of that multiplication is going to get cast up to whichever one is bigger. So I probably don't need to make all of these I-64, but why not? Just in case like I miss something and it ends up overflowing. Okay. This one I'm not going to bother with. I-32 is fine there. And it's still a limit of 100. Oh, yeah, many more than 100. Okay, so we're not going to have that limit. I'll get rid of that in a second. That should work. Like I shouldn't have to cast those up. Pretty sure I don't need to cast the zeros up. Then what am I gonna do here? Do we ever get multiple solutions? Unless they're collinear. One solution, yeah, so there's only one solution anyway. Let me print a new line to make that more obvious. Yeah, there's only ever one solution. Maybe run it on the real input. Because if things are collinear, then it's kind of singular. It's like I'm looking for any time that we get two costs printed in a row for the same claw game. And we're like over 10% of the way through the file already, so I think I can just look at all of them. Or I could just check that Boolean. Okay. So let's look at this again. We have a matrix problem. Minimizing is not a concern because we never have multiple solutions. So let me just copy that again, and we can just look at this. This is a matrix problem, and you can just find this solution by inverting this matrix. And for a 2x2, there's a simple formula for that. Can I remember what it is? Something to do with the determinant. So the determinant is ax times by minus ay times bx. So you divide by that, and then I think you swap the diagonal terms, and then you keep the off-diagonal terms in place, but you negate these two. So I think the inverse is by negative bx, negative ay ax. Let me get these lined up. All of that whole matrix divided by the determinant. I think that's the inverse. So let me do that. We could just see if it works, right? Okay, so we're not going to loop because that's a death spiral. That's going to be, it's going to be this formula. Okay, I just don't want to forget to calculate that and then like sum up just what this was initialized to. Actually, yeah, let's just not even declare it up there because we're going to calculate this in one shot. And then we're going to have a determinant. Ax times by minus ay times bx. Is that what I had? Ax by minus ay bx. Yep. Could have copied and pasted. And then let's copy and paste this at least. So we have a matrix problem. 2x2, not the biggest matrix. So we're going to invert the matrix and find solution NA, NB. That's the unknown. We know the right-hand side, PX and PY, and we know the matrix, but the unknown is this, so we have to invert the matrix and multiply it by that to find the solution. And let's just not worry about rounding error. I think we have to compute the solution and then check if it matches to make sure there's not any rounding error. Hopefully everything should divide evenly, but like if there's a remainder, then you might not have an actual solution. So first of all, if the determinant is 0, that's singular. And we're just going to skip it. Actually, singular would mean there are multiple solutions. So I think I want to do something here. From the log that I looked at where we were logging the cost here, I never saw multiple solutions. So I'm pretty sure this doesn't happen. And then, yeah, we're going to calculate the solution. So, I think I have to declare them because I don't think I've declared them yet. We're going to swap by. And then minus. Is that right? Doesn't look right. By negate bx. Oh, divide by the determinant. And then, what is this one? Negative ay times px plus ax times py. Divide by the determinant. If you don't know that, you have to look it up, or you can derive it from algebra. Like you can solve the first equation. Let's not look at the matrix equation. You have to look at it as a system of two equations, and then you have to solve this one for one of the unknowns in terms of the other ones. So pick by, for example. Rearrange this to solve for by in terms of everything else, and then substitute that into, no, by is not an unknown. Solve for nb in terms of everything else, and then substitute that formula for nb into here, and then solve that formula for ax. So you can basically derive this matrix formula by doing 5 to 10 minutes of algebra if you're good at algebra. If you forget, it might take you a little bit longer. But this is not just something that I pulled out of my ass. It's something that you should be able to derive in 10 minutes. 20 minutes if you know high school algebra. Yeah. So I think that's the formula. I think might not even need to do this. This might just kind of work. Yeah, so we've calculated this, we've calculated that, so then we should be able to get the cost. And then what is my no solution case? So if you have a singular matrix, yeah, a singular matrix could mean multiple solutions, or it might mean no solutions. So actually, I think I'm probably going to have to just continue in this case. But let me see what happens. I think we are going to hit that case. Okay, first of all, bx. Yeah, these things are vectors. Let me just unpack my vectors into scalars here. So, so that I don't have to like update everything that I wrote here. AX is VA0. AY is VA1. Hey, Scaly, thank you for the raid. Were you doing AOC today, or what were you working on? It's going good. I'm done with part 1 for Advent of Code here, and now I'm chugging through part 2. I happen to be pretty good with linear algebra, so I think I know how to solve this. If I didn't know anything about linear algebra, this might have been tough. Then some Binding of Isaac modding. I don't know what Binding of Isaac is. Are you on day 13 for Advent of Code? Or are you catching up? Okay, so I forgot to declare. Okay, done with 13. Cool. And I like my chances here. My code is not compiling because I forgot to declare some variables. I still forgot something. Okay, px and py. I have to unpack those. Oh, it's a roguelike game. So is that a role playing? Is that an RPG? Px is gonna be VP0. I'm expecting something. Okay, I haven't added 10 trillion yet. What did I submit for part 1? I should be able to at least reproduce the answer from part 1 before I do anything else, and it looks like I didn't. 31,065. Right, there's way too much printing here. I'm surprised we didn't hit this. That seems wrong. AX times BY minus AY times BX. I think that's the determinant. Type all of these correctly. A, B, P, 0, 1, 0, 1, 0, 1, XY, XY, XY. That looks correct. It's a kind of dungeon crawler. That's interesting. Oh, by the original Zelda dungeons. I never played the older Zeldas. I played Ocarina of Time, and then I played part of Majora's Mask, but I never beat Majora's Mask. Okay. So why? I don't think I need this Boolean. Hey, Vision for All. Welcome back to the stream. Oh, you only recently played. How do you play them? Do you have a Switch or do you have like an emulator? Okay, I think I need to check if my solution is actually a solution or if I had like rounding error that divided by the determinant and just pretended that I had a solution. Okay, you have an emulator. I should do that because I really liked Ocarina of Time, and I hear good things, I think especially about A Link to the Past. Yeah, you had some rounding errors. Yeah, I had a note for myself, and I was like, well, let's see what happens if I don't add any extra logic. So I think I have to check if this is really a solution. So that's going to be NA times AX plus, let me just do the vector. Oh yeah, there's a thing that you can get on Nintendo Switch where you can play the old games. Okay, yeah, so that's the official way to play it. Let P, I think I already have, oh, it's VP. Okay, so I can just call this P. Emulator might work. I see people on like TikTok lives playing old Zelda games. So I bet that's probably how they do it because I don't know if you can stream from a Switch. Okay, so I could just write like a matrix vector multiplication function. I think I have one of those laying around somewhere, but this is two-dimensional. It's easier to do. To just write it out in 2 lines. Does Syntran have integer division? Yeah. So if you have an integer on the left-hand side and then an integer on the right-hand side, it will just do integer division and take the remainder. If you wanted to get like an actual floating point value, you would have to cast it. You could do something like that. This one, it would force the numerator to go up to a float, and then float divided by an integer would just give you another float. like slash slash. No, I just use one slash, but it is integer division. Python, the reason Python has that is because I think if you divide an integer by an integer, it gives you a float, unless you use slash slash. So I think that's kind of a weird design for Python. That's not the way that this works, but there is integer division. Okay, so this should be NA times AX plus NB times BX. And then the other component is just the Y's. Yeah, and then we can check if we have a solution. So if not all P equals VP, we're going to continue. And then that will not add up the cost. No, I can't just continue because I need to skip these blank lines. That's kind of annoying. Yeah, I should have not done this in the loop. I should have made a function for that. Okay, so if they are equal, then we're going to add it up. Okay, it's only 2 lines that I have to indent. That's not that bad. So can I reproduce the part 1 solution? 31065, that sounds different. Okay, that's what I got for part 1. Now I have to add 10 trillion to everything. So I already have this number hard-coded. I just need to add it to P. So I think I can do VP plus equals add. The slow part here is part 1 because I did part 1 the brute force way. And now it's printing all zeros, so that's not good. It worked. It worked for without adding the position. But now when I add 10 trillion, it doesn't work. I might have, oh, these are all, I think I have to cast up. Probably don't have to cast up everything, but I'm going to cast up everything to I64 just to be safe. I64. I've had something like that too. 32, but it's not okay. Like there's an overflow and then you don't get a runtime error, you just get a garbage answer. I don't know. I don't know how to do anything about that. For performance, that's probably the best thing to do. If you have code that's like always checking for overflow, then that's going to slow down your code. And you wouldn't want that for like a high performance program. But there should be like some kind of debug version where it traps that and then gives you a runtime error instead of giving you a garbage result. Okay, so I think that casts up all the important stuff, and then everything else should be inferred. So if the whole right-hand side is 64-bit, this thing should be 64-bit. And it's still safe to compare it to a default 32-bit 0 there. So hopefully, let me comment out part 1 because that takes too long to run. Hopefully that should not give me a 0. Okay, that's a number. That's better than 0. I've got a good feeling about this one. Okay, it helps to know linear algebra. How long have I been streaming? 50 minutes? I think that's not bad for day 13. We're like halfway through Advent of Code. Maybe this weekend they'll start getting harder. Thanks, guys. I still have to commit this code. Yeah, let me just clean it up quickly and commit it, and then we can find somebody to raid. So there's part 1. Let's comment all the logging. Yeah, so apparently you never get a singular matrix. I thought I might have to do something about that. So I just panic. I exit with a failure code if you ever hit that. I am checking for rounding error. That's what this does. And And any other prints, I think that's cleaned up. That should run. It says part 1, but really it's part 2. And then let's uncomment the call to part 1. This should say 13. Okay. I think that's it. I've untracked stuff from trying to play with day 11 and make it run faster. But I think I committed everything here and I committed too much. Why not keep the notes? The notes is where I laid out the matrix math. AOC 2024, day 13. All right, let's find somebody to raid. I don't know if anybody else is still doing AOC. Maybe not. What is Zorkenheimer doing? Or Zorchenheimer?
Let's get some other like.
Oh, making a Tetris clone. Didn't this stuff used to be below the videos? Now it's at the top, and like I'm not looking for it there. I don't think Hipsmurf. Yeah, I don't think anybody else is doing Advent of Code, but I'll give Zorkenheimer a raid. He frequently programs in like COBOL and fun old languages like that. So he's making Tetris. I don't know if you can ASM. Okay, I think he's doing assembly right now. Yeah, we're going to give him a raid. Zorchenheimer. Raid. Is it capital Z? I think I'm not logged in here. Okay. All right, thanks to everybody who tuned in. I really appreciate it, and I will catch you next time. Bye.
You're crushing it. Oh, Jeff Irwin, how you doing? Welcome. How you doing? What were you working on? All right, JSR rotate. Center pointer, how you doing? Welcome. Rotate block. A. This is Advent of Code. Nice. I haven't started this year's Advent of Code. I don't think I'll do it on stream this time. This year, if I start it up, I'll probably do it. I'll probably start later on into the month when there's more of them to pound through. Scale Games, how you doing? Welcome. So we're working on implementing Tetris. Am I on Twitch? Yes, Mark, I am on Twitch. Yeah, that's what all that there is. I don't have the YouTube chat anywhere because I'm too lazy, honestly, for being real. Can I just talk? I'm mentioning it because that's what Jeff was doing. Yeah. You can binge it if you start like, yeah, that's the idea anyway. I don't know how well that works out for me usually because I don't usually get very far in the Advent of Code. I've started it a bunch different years, but I've never completed one. Yeah. Are you taking like different rotation systems into account or some basic Tetris implementation? This is all specific to Tetris stuff. Right now, I